Hello, this is Sujit. Welcome to my channel Physics 2020. Today I come with another topic, differentiation, mathematical support for physics part 2, differentiation. In the previous video, mathematical support for physics part 1, trigonometry. In that video we discussed fundamental trigonometric ratios, fundamental trigonometric relations, T ratios of allied angles, and finally some important formula in trigonometry. So if you didn't watch that video, go to Physics 2020 and watch the video Mathematical Support for Physics Part 1, Trigonometry. So in this video, Mathematical Support for Physics Part 2, Differentiation. So in this video we are going to discuss what is the rate of change of a function, what is the derivative, what is the tangent to a curve, what is the slope of the tangent, what is positive slope, what is negative slope, a standard function y is equal to x power n, and its a derivative, its proof, and finally we discuss the function y is equal to sin x and its derivative, the sine and cosine curve. So these are the things we are going to discuss in this video. Dear friends, dear students, if you didn't subscribe my video, subscribe my channel Physics 2020. Please subscribe my channel. Also press the bell icon for the notification of the upcoming videos. Dear friends, if you are thinking it is very useful for learning physics, please share this channel to your friends also. Done. So we start with differentiation. Differentiation. So what is differentiation? So the word meaning of differentiation is to differentiate or distinguish two or more things. That is the meaning of differentiation. So in mathematics, what is the meaning of differentiation? So differentiation is a branch of mathematics that deals with rate of change of a function. Rate of change and derivative. Okay, derivative. These are the things which are dealt with differentiation. So suppose x and y are two quantities. X and y are two quantities. Y depends on x. In such a way that y is equal to x square. So for each and every value of x, there is a unique y value. Okay, there is a unique y value. So we have the table of x and y. So x, y. Okay. So x has the value that is 0, 1, 2, 3, 4, 5. Okay. Y is equal to x square, that is 0, 1, 4, 9, 16, 25. Okay, 25. If you plot these values in a graph, what we will get? So I am drawing a graph. This is x, this is y. Okay. So we will get a graph like this. Okay, graph like this. Suppose A is a point. In the graph. A of x comma y. A of x comma y. So the x value can be get by drawing a coordinate into the x-axis. So this is origin. So this point is at a distance x in the x-axis, y distance in the y-axis. Okay. Suppose x is changed by the value delta x. X is changed by the value delta x. Correspondingly, y is changed by the value delta y. So we get another point, that is B. B. Okay. So this is delta x. Delta x. Okay. This is y. So this is delta y. Okay, delta y. So A, B, C. Okay, A, B, C. So we will get that if AB is a chord. AB is a chord. So this is a right angle triangle. This is the angle theta. This is the angle theta. So we are going to define rate of change. Rate of change. So if x value is changed by delta x, correspondingly the y value is changed by delta y. The rate of change is defined as delta y by delta x. Delta y by delta x is called the rate of change of y with respect to x. Okay, respect to x. So A is a point x comma y. B is a point x plus delta x comma y plus delta y. Right? So rate of change is equal to delta y by delta x. So if x is changed by delta x, correspondingly the y is changed by delta y, then rate of change is defined as rate of change is equal to delta y by delta x. Delta y by delta x is equal to y plus delta y minus y divided by x plus delta x minus x. We can write this. So the distance delta y means y plus delta y minus y. So we will get delta y. Okay. So delta x equal to x plus delta x, so minus x. So x plus delta x minus x. Right? Suppose P of PQ is a line. PQ is a line. P of x1 comma y1. Q of x2 comma y2. x2 comma y2. y2 minus y1 divided by x2 minus x1. So in the lower class we studied y2 minus y1, x2 minus x1 is equal to slope of the line PQ. Slope of the line PQ. So similarly, so AB is a chord. AB is a chord. So b of a of x comma y, b of x plus delta x comma y plus delta y. So y plus delta y minus y divided by x plus delta x minus x. So what we will get? Yes, delta y by delta x equal to y plus delta y minus y divided by x plus delta x minus x. That is equal to the slope of the chord AB. It's equal to slope of the line. Slope of the line. Okay. Next, from the graph, consider this triangle ABC, right angled triangle. Okay, right angled triangle ABC. So I am writing delta y by delta x, that's equal to y plus delta y minus y divided by x plus delta x minus x. That is equal to y plus delta y minus y. That is delta y. So delta y is this distance, that is BC, divided by x plus delta x minus x or delta x. Delta x equal to, that is AC. AC. So that's equal to BC, that is perpendicular divided by, so AC, that is base. So what is perpendicular in a right angle triangle? What is perpendicular by base? That is equal to tan theta. It is equal to tan theta. Okay. So finally, we will do the conclusion. So what we can conclude? From the graph, what we can conclude? Delta y by delta x, delta y by delta x, that is rate of change, is equal to slope of the line AB, that's equal to tan theta. That's equal to tan theta. Okay, that is very important. Delta y by delta x, that is rate of change, is equal to slope of the line AB, which can also be determined by, that is tan theta. Okay, tan theta. But delta y by delta x, that is rate of change, that is equal to slope of the line AB, that's equal to tan theta. But is it a precise rate of change? This delta y by delta x is a precise rate of change? No. This is the rate of change within an interval, that is delta x. Okay, delta x. So suppose delta x is equal to 1 unit or 2 units. It is also a very great interval. But if you closely observe the graph, for each and every point, the y value is varying. Not only within this interval, each and every point of x, value of x, the y value is varying. Okay, varying. So how can we find out? So Suppose reduce the value of delta x. Reduce the value of delta x. Correspondingly, delta y value also reduce. So you find that delta y by delta x. Within that interval also y value is varying. Again you reduce the value of delta x. So within that interval also y is varying. So from the graph we can understand. Again reduce the value of delta x. So delta y also correspondingly reduce. So what will happen? The point B approaches to A. So when you reduce the value of delta x, correspondingly delta y value also reduce. So it will approach, the point B approaches to A. Suppose the delta x value is equal to some 0.00001, like that. So not equal to 0, some 0.0001. That is, the point B approaches to A, that is, and the point B coincides with A. Now there is no more this line AB. There is a line which passes through the point A alone. A alone. So when you consider such a very close interval, that is, we can say delta x tends to 0. Delta x tends to 0. So at that time, the rate of change of y with respect to x within such a very close interval, very close interval, we can say that the rate of change of this function is called dy by dx. dy by dx. At that moment, this line AB disappears and there is a line which passes through the point A alone. That line is called the tangent of the graph. Okay, tangent of the graph. That is, a line which passes through the single point. The line which crosses a single point of the graph is called the tangent of the graph. So at that moment, again dy by dx equal to, so we have, that is tan theta. Tan theta is the slope of the tangent. At that moment, tangent dy by dx equal to tan theta is the tangent of the, slope of the tangent. Slope of the tangent. Now you clear, that is dy by dx. First understand delta y by delta x. It is a rate of change of the function within that interval. So if you reduce the value of delta x, so correspondingly delta y also reduce. The line AB is diminished or shrinks. That line shrinks and the point B approaches to A and the point B coincides with A. So the line AB completely disappears. There is the line which passes through only the point, that is through the point A. So at that moment, the rate of change is, we will represent that is dy by dx. Okay. At that moment, the rate of change is called dy by dx. At that moment, the line passing through the single point of A is called the tangent of the curve. So dy by dx equal to tan theta, that is equal to slope of the tangent. So for dy by dx, so dy by dx equal to limit delta x tends to 0. Limit delta x tends to 0, delta y by delta x. Delta y by delta x. It is a very important form. So dy by dx equal to limit delta x tends to 0, delta y by delta x. So delta y by, in the previous case, delta y by delta x, it is the average average rate of change of the function. Average rate of change. Average rate of change. So dy by dx is the instantaneous rate of change. Instantaneous rate of change. So if you consider such a close interval, that is the point B approaches to A, and the point B coincides with A. So there is no more line. This AB line completely disappears, and there is a line which passes through the point, single point A. That line is called the tangent of the curve. At that point, tangent of the curve, but at that moment, we will call that is rate of change is called the dy by dx. So dy by dx. So dy by dx, that is the rate of change when that is limit delta x tends to 0. Delta y by delta x. So delta y by delta x is the average rate of change. Dy by dx is called the instantaneous rate of change. That is the rate of change at this point. That is A. You understand? Okay. So when you consider the instantaneous rate of change, that is instantaneous rate of change. So this is a curve. So A is a point, B approaches to A, and B coincides with A. Okay. So this is the tangent. So A, this is the tangent at A. So at that moment, the average rate of change is dy by dx. Okay, dy by dx is equal to tan theta. So tan theta is the slope of the tangent. So that's very, very important. Okay. So this is the point A. So theta. Okay. So now at this moment dy by dx. It is the instantaneous rate of change. At the point A. So is equal to, so what is the formula? Limit delta x tends to 0, delta y by delta x. Okay. So dy by dx, which is equal to tan theta. So theta is the slope of the tangent. So that is very important. Slope of the tangent. So next we are going to see positive slope and negative slope of a tangent. Okay. Positive slope and negative slope. Positive slope and negative slope. Suppose if y increases with increase of x of a function. Suppose y increases with increase of x in a function. Then the slope is positive. So what is slope? Slope is equal to dy by dx is equal to tan theta. Okay, tan theta. If x increases, if y increases with increase of x. So how the curve? The curve is like this. Okay, the curve is like this. The curve is like this. Okay. Okay. This is the tangent. So which makes an angle theta. Okay, theta. So in this curve, the theta has the range of value. Theta has the range of value theta greater than or equal to 0 and less than or equal to 90. So in any of the point, if you draw the tangent, so the slope of the tangent has the range, that is value, that is theta has the value, that is 0 and 90. Okay, so 0 to 90 means in the first quadrant. Okay, first quadrant. First quadrant tan is positive. First quadrant. So first quadrant. Okay, 0 to 90 means first quadrant. First quadrant tan positive. So slope is positive. That's why I told, if y increases with increase of x in a function, the slope of the tangent is positive. Okay, positive. So whatever the tangent, in any of the point, if you draw the tangent, it has the angle that is within this range, 0 to 90. Okay, 0 to 90 degree. Okay, 0 to 90 degree means first quadrant. First quadrant tan is positive. So tan is positive means the slope of the tangent is positive. Okay. Then next is negative slope. If y decreases with increase of x, slope is equal to negative. So slope is equal to dy by dx equal to tan theta. Okay, tan theta. So y decreases with increase of x. So this is the tangent. So this is the angle theta. Okay, theta. So in any of the point, if you draw the tangent, so theta has the value that is 90 greater than or equal to less than or equal to 180. Okay. If any of the point, if you draw the tangent, the theta has the range of value that is 90 greater than or equal to and less than or equal to 180. So 90 to 180 It is in the second quadrant. 90 to 180, second quadrant. So second quadrant, tan negative. Okay, tan negative. So 0 to 90, 90 to 180. So 180, that is all here silver. Okay, silver, here tea cups. So here sine and cosec is positive. So here tan is negative. So tan is negative. So the slope is negative. Slope is negative. So if y increases with increase of x, the slope of that such curve is, slope of the tangent of such curve is negative. Okay. So dear students, if you are not thorough with the four quadrants and which functions are positive and which functions are negative in the four quadrants, means you, that is in the go to the channel Physics 2020 and watch the video, that is trigonometry. Okay, trigonometry. In that video we are clearly discussed. Okay. So we studied the rate of change del y by del x, the instantaneous rate of change dy by dx. So the slope of the tangent, that is equal to tan theta, that is equal to dy by dx, that's equal to tan theta, and the positive slope of the tangent and the negative slope of the tangent. So next we are going to see a standard function. So y is equal to x power n. Y is equal to x power n. So its derivative is dy by dx equal to n into x power n minus 1 into x minus 1. So proof. So this can be proved by first principle of differentiation, using first principle of differentiation and applying the rules for the limits. So actually you will study all these things in mathematics. For the time being, I am just giving introduction. That is, next we are going to see the formula in differential calculus, all the standard formula. So for at least one formula I would like to prove. Okay. So this can be proved with the first principle of differentiation and applying the rules for the limit. Applying the rules for the limit in the sense, the denominator value cannot be 0, should not be 0. The logarithm of, that is, negative values cannot be applied. So such things. Okay. Rules of the limits. Anyway, y is equal to x power n. So dy by dx equal to n into x n minus 1. Okay. So f of x equal to x power n, or so f of x equal to x square. F of x equal to x square. I am taking f of x equal to x square, or y is equal to x square. Okay. So by formula, that is n into x power n, that is dy by dx equal to 2x 2 minus 1, that is 2x. Okay, 2x. By first principle of differentiation. First principle of differentiation. Delta y by delta x equal to f of x plus delta x minus f of x divided by delta x. Okay. Delta y is equal to f of x plus delta x minus f of x. So dy by dx equal to limit delta x tends to 0 f of x plus delta x minus f of x divided by delta x. So f of x equal to x square. So that's equal to limit delta x tends to 0. So f of x equal to x square. Appo f of x plus delta x equal to x plus delta x square minus f of x equal to x square divided by delta x. Okay, delta x. So that's equal to limit delta x tends to 0. So a plus b the whole square. So x square plus delta x square plus 2x delta x minus x square divided by delta x. So that's equal to limit delta x tends to 0. Delta x tends to 0. X square cut. Delta x square plus 2x delta x divided by delta x. So that's equal to limit delta x tends to 0. Take delta x commonly outside. So delta x plus 2x divided by delta x. Delta x cut. So limit delta x tends to 0. So delta x plus 2x. Now you apply the limit for the delta x. So put delta x equal to 0. So dy by dx equal to 2x. So dy by dx equal to 2x. So this is the proof of the standard function, that is y is equal to x power n. Next is y is equal to sin x. Dy by dx equal to cos x. Okay. So y is equal to sin x function. So its derivative is dy by dx equal to cos x. Okay. Cos x. So we are going to discuss the sine curve and the cosine curve also. Okay. This x, this is y. Okay. This is the sine curve. So this is 0. This is pi by 2. This is pi. Three pi by 2. Okay. This is 2 pi. Okay, 2 pi. So 0, 30, 45, 60, 90. Sin 0, 0, sin 30, 1 by 2, sin 45, 1 by root 2, sin 60, root 3 by 2, sin 91. Sin 91. So sin 0, it starts from 0 and it when goes to 90 degree, that is it is gradually increasing. So it is increasing. Okay, sorry, pi by 2, 90 degree. So it increases. Okay, so in the first quadrant, sign is positive. Again that is 90 to 180. 90 to 180, again it is positive but it decreases. Okay, decreases. So 90 plus theta, the first quadrant also sign positive. Sign positive. Okay, in the second quadrant, that is 90 to 180 degree. So sign positive. Okay, in the first quadrant all positive, so sign is positive here. So in the second quadrant, sign positive. Okay, so then so cosine curve. Cosine curve. So cos 0 is cos 0 1 30, that is root 3 by 2, 1 by root 2, 1 by 2, 0. So cos value decreasing. So it starts with the maximum. So x and y. Okay, x and y. So it starts with the maximum. Is the cosine curve. So 0, that is starts with maximum, and so this is 0, this is pi by 2, this is pi by 2, this is pi by 2, this is pi, this is 3 pi by 2, and this is 2 pi. Okay, 2 pi. So cos starts from the maximum value, and when it reaches 90, it becomes 0. Okay, so 92, so 90 to 180, 90 to 180 in the second quadrant all silver, so cos negative, so it will in the second, so see after reaching 0 it will go in the negative direction. So 180 means minus 1, minus 1 means it will the negative maximum, and it's in the negative side it increases. Okay, increases. 3 pi by 2 again 0, then 2 pi by 2 is maximum. So this is the sine and cosine curve. So in the next video we will discuss all the standard formula in differentiation. Okay, differential calculus, all the standard formulas, and short problems also we will discuss. So this is the first part of the differential calculus mathematics help for physics. That is part 2A, that is differentiation part 2A. In the next video part 2B. So we will discuss the remaining all the formula in differential calculus in the next video, and little bit small short problems, that is u by uv method of differentiation, u by v method of differentiation, and a chain rule of differentiation, and finally the maxima and the minima of differentiation we will discuss in the next video. Stay tuned. Thank you.